All right, so the last type of transformation we're going to talk about are dilations. And so the dilation deals with the a value on the outside. It can also deal with a value in front of the x here, but we just don't see that very often. The a value on the outside means that it's a stretch. So if it's right here in front of the x, it's a compression. It changes the x before the y gets evaluated. The change in the front, the a here, is a stretch though. And so graphically, the thing to look at, because we're always going to see it like this, if the a value is greater than 1, everything goes closer to the y-axis. When you go to graph it over time, it wants to hug the y-axis whenever it's bigger. If it's smaller than 1, it's going to want to move closer to the x-axis. So, for instance, 3x squared plus 6, I'm going to go ahead and first put my vertex. That's going to be up 6. 1, 2, 3, 4, 5, 6. So here's our starting point. But this 3 means it's going to hug the y-axis even more. So where this U shape was sort of like in between, this is going to be skinnier. It's going to go up a lot faster. All right, negative 1/2 times x minus 7. So we're going to go right 7. 1, 2, 3, 4, 5, 6, 7. And it's going to go negative, so down from left to right. But this is a 1/2. So if this was a bigger number, we would be going steeper, closer or faster to the y. But since it's less steep, it's 1/2, it's going to be more like this, where it's actually a little closer to the x. It's hard to see here; they almost look the same, but this is hugging the x a little bit more. Okay. Next guy, plus 2 moves up 2. 1, 2. The 2 in front means it's going to be a skinnier V shape, like that. Negative 2/3 times x minus 1 squared. So this is to the right 1. And this is going to be upside down. And this is actually a little less than 1. So this is going to be less steep. It's going to be less of a hugging to the y. So this is going to be a little bit fatter. It's going to be hard to do that. Okay, something like this. So it's a little bit fatter than this one, and the reason is because this value here is less than 1. Alright, so absolute value, or excuse me, 4x plus 4. So first off, we're going to go up 4. 1, 2, 3, 4. And this 4 is super steep. So where this is a 1, we're going to go like this. See how it's much steeper, like climbing up a mountain? It's very steep, harder to climb. Okay, down here to the bottom left, right 3. 1, 2, 3. Negative, so upside down, and 2 means a little skinnier. Okay, 1/4 x plus 2 squared. So we're going to go left 2. 1, 2. That's where we're going to start off. And this is happy face. There's no negative here, but you can see this is 1/4. So this is a lot less skinnier. This is going to be fatter. It's 1/4. For every change in the y, it's 4 changes of the x. So something like this would be 1/4. All right, negative 4 times x plus 6. So we're going to go left 6. 1, 2, 3, 4, 5, 6. Super steep, but going down because it's a negative. All right, 1/2 times x plus 3. So we're going to go left 1, 2, 3. And 1/2 means a little bit fatter. It's not super, but it should be obvious that this is a little bit fatter than the previous one. And then finally, negative 3x squared minus 3. We're going to go down 1, 2, 3. And then negative, so he's upside down, and the 3 means super skinny. Something like this. And that's it. Those are the 3 transformations that we need to remember that tells us what to do with our functions.